Welcome to our lecture online. Just like in the previous video, our integral is still the sine cube of x divided by the cosine cube of x. This is now going to be method 2 to solve this integral, and just so we can see what the answer was on the previous video using method 1, we have it on the board. So what we're going to do here is use a different trick. We're going to use the same trick we did in the previous few videos before that, where we take the numerator and write as a product of the following. So we're going to write this as the integral of the sine square of x times the sine of x in the numerator divided by the cosine cube of x in the denominator. Of course, we still have the dx. And then we're going to write the sine square of x as 1 minus the cosine square of x. So this is a typical trick. So this becomes equal to the integral of 1 minus the cosine square of x. Still have the sine of x divided by the cosine cube of x dx. So the next thing we're going to do, of course, is write it as two separate integrals, and then we hopefully can integrate both of them separately. So when we take our first one, we have the sine of x times 1 divided by the cosine cube of x. So this becomes the integral of the sine of x in the numerator. We have the cosine cube of x in the denominator times dx. And then we have a minus. Notice when we multiply these together, we can cancel out the cosine square and two of these. So we end up at minus the integral of the sine of x divided by the cosine of x times dx. Now the second integral is easy to integrate, and so is actually the first one when you assume over here that u is equal to the cosine of x. So here we're going to let u equal the cosine of x, so we end up with u cubed in the denominator. And the numerator, well, then du is going to be a minus sine of x dx. And we realize then the only thing we're missing is the negative sign here, so we put a negative sign in front. Same over here, we're going to let the denominator equal u, so that we have u as the cosine of x in the denominator. We need a du in the numerator. Again, we need a negative sign in the front, and then of course we need another negative to compensate for that. And notice that those two negatives will cancel each other out. So now we're ready to integrate. So this becomes equal to, let's see, the two negatives. Well, this negative is still there, so we have the negative of the integral of du divided by u cubed over here. And then we have a minus times a minus, that gives us plus. And here, since we have the du in the numerator, we have a u in the denominator, that becomes plus the natural log of the cosine of x, plus we have a constant of integration. Now integrating this becomes u to the minus 3, add 1 becomes u to the minus 2 divided by a negative 2. So this becomes minus u to the minus 2 divided by minus 2. And then here we have plus, we have plus a constant of integration, then plus the natural log of the cosine of x plus c1. And then, of course, the two negatives cancel out. This goes to the denominator. So this becomes equal to 1 over 2, 1/2, times 1 over u squared. And u was the cosine of x. So that becomes cosine squared of x in the denominator, plus the natural log of the cosine of x, plus a combined constant of integration. And this is our new answer for the very same integral. Now when you look at what we have here, what we have there, we do see the natural log of the cosine of x plus c, that's the same. But here we have 1/2 times the tangent square of x, and here we have 1 over 2 times the cosine square of x. And they are not the same. And when we start plugging in numbers for x, we don't get the same answer. Wait a minute, what can we do? What can we do to show that those two are actually equivalent to one another? Well, if you want to know how we do that, stay tuned and we'll do a video on that as well.